Library Instruction Tennessee provides space for teaching librarians to network, collaborate, and discuss trends, issues, and innovations in library instruction and information literacy. We would like to thank the Citadel Library for providing Zoom access for our conference. And want to let you know that this session is being recorded. So by continuing to attend the session, you are consenting to being a part of that recording. After the conference today, sometime in the next week or two, we will get the recordings of all the sessions posted onto the LIT website with captions. We ask all attendees to abide by the LIT Code of Conduct, which can be found on the About Us page of the LIT website. If you need to report any issue related to that, please email us at libraryinstructiontn@gmail.com. We have disabled your microphones for now, at least. So if you have questions during the session, you can put those into the chat box, and hopefully we'll have some time for a little Q&A at the end. But yeah, go ahead and use the chat box for now. If you have technical issues, please shoot an email to libraryinstructiontn@gmail.com. After the conference today, we're going to send out a survey to ask you, for feedback and ways that we might be able to improve LIT in the future. So please watch out for that email from us. We really would appreciate your feedback. All right, now that I've got all that out of the way, this session is titled Best Practices Working with Spatial Data. Our presenters are Dr. Stacy Curry-Johnson of Vanderbilt University Libraries, and speaking with her today is Natalie Robbins, also of Vanderbilt University. So with that, I will turn it over to our featured speakers. Thank you.
Great, thank you. And thank you so much for having us today to speak with you about a subject that we're passionate about, working with spatial data, and have some best practices for that. I'm going to speak a little bit about what we're going to talk about today, introduce Natalie, and then we'll get into it. So let me get set up here, and then we'll get started. Always takes me a moment. Okay. Sure. Are you able to see my window, Natalie? Yep. Excellent. All right. Like I said, this is best practices for working with spatial data. And don't worry if you don't know what spatial data is quite yet, we'll get into it. So who am I? I'm Stacy Curry-Johnson. I am the geospatial librarian at Vanderbilt University. I also teach in the anthropology department. I teach the intro to GIS and remote sensing. At Vanderbilt, I work on project consultations. I help students and faculty. I also work with administrating our GIS system through our enterprise license for ArcGIS. And I'm also the co-PI on a project called the Battle of Nashville, which we'd love to talk to you about at some future point. But also I work with Natalie quite a bit. And let me let Natalie introduce herself.
Hi, I'm Natalie Robbins. I'm a research analyst in the Spatial Analysis Research Lab here at Vanderbilt. I basically serve as a high-level geospatial consultant for projects across the campus, as well as the medical center, and also co-instruct a course about critical spatial inquiry in the Peabody College and work on that Battle of Nashville project that Stacy alluded to. And her and I sort of serve as foils for each other at Vanderbilt, helping to bridge the gap between like geospatial technology help and then geospatial instruction and geospatial consulting.
So it was a great segue into kind of the background of how this got started, how we started getting into talking about best practices, and it's through our GIS instruction that we do. So here at Vanderbilt, we don't have a geography department or a geography program that can really teach about GIS and geospatial research. So that's where Natalie and I come in. I come in it from the library standpoint, and she comes at it from the research side. So this lack, we do have the one course that I teach, but other than that, there's a lot of demand for geospatial instruction. And so between Natalie and I, we both can reach out to reach different faculty members and different students that one of us on our own could not do on by ourselves. We have a wider array of expertise together, So this is why our partnership's so great, is that we both have strengths in different parts of the subject matter. And then we were able to produce standardized GIS instructional materials and workshops that we can repeat and be useful from semester to semester. And we can provide hands-on workshops that would be very difficult for just one person to do and make them more interactive and enjoyable for a larger audience. We can also together stay up to date on new technology and new research to make instruction more relevant to ongoing research at Vanderbilt. Also, the COVID-19 ignited so much interest in GIS that there's dashboards that we saw maps everywhere. And so maps have continued to be everywhere since, and all sorts of different subjects because it's become a daily consumable. So that's piqued the interest on campus for more GIS instruction. And so we created a workshop series together that we, and each year it seems to get more and more added onto our workshop based on the demand and need that we perceive. But we've created, and at the end of this talk, I will go over our workshop series for this semester and just show you what we've created in terms of offerings. And we offer these for about 2 hours, once a week, every other week. And these include offerings like QGIS, ArcGIS, ArcGIS Online. This year we added georeferencing, best practices for handling spatial data. And this is one of those topics that came out of our workshop series that we found quite successful. So what is this need for spatial data? I'll go into it in a minute, but we found that spatial data needs to be handled and acquired differently than just your standard data that you would get. And people don't often realize that. So having some kind of best practices or workflows for dealing with a geospatial project comes in handy. And we kept running into students and faculty that have the same questions about these issues. And so we said, why don't we just do a workshop and write it all down and create a tutorial? At the end of our talk, we'll talk about the tutorial that we created that we'll share with you that hopefully you might find helpful if you happen to work with a geospatial project. Okay, and you can see us here in our picture doing our field work, which we do many different types of work, but this is one way, working with the GPR, or ground penetrating radar. So before we even get started, I just want us to think spatially for a minute. So what does thinking spatially mean? Well, it means a few things. It can mean about place, so an important location, whether it's a real location or a conceived location. We can talk about space, so that distance between points, so point A to point B. It can be, and that can also be time too. You can add a time element into that as well. Spatial, which can mean related to or existing within space. And geographic, where something is on the Earth's surface. Geospatial, which is a catch-all term. It's different than GIS, which I'll describe in a moment, but geospatial refers to everything about space, any technology, any type of space, any type of analysis that regards to a location or space. And spatially can also be thinking with real space or sociocultural space or constructs of geography. So these are all ways that we can start to think about space and what it means to think spatially. So what is spatial thinking in research? Well, I like to say that it's applying geographic principles of place, that time element, and distance. If you have one of these things or all of these things, then you have a spatial problem. You're thinking spatially. So your ability to conceptualize research questions and methods that involve place, distance, and time, and the ability to integrate different forms of spatial data and explore different patterns. So exploring spatial patterns is a very common research question that you have. So what is GIS? Because we talk about spatial data, but spatial data works within the GIS world. So GIS, if you're not familiar, is Geographic Information Systems. So the geographic is the where, information about people, places, kind of sounds like social studies when I was in school, but studying about people and places where location is based. So you have a coordinate system, you have X, Y, you have latitude and longitude. You have an area code or a zip code. You have a street address. Those are all geographic components in a GIS. I think we have a raised hand. I can't see you, so do I need to do something with that?
Sorry, I did not see the hand. You can type in the chat.
Okay. Maybe
I would just keep on going.
Okay, maybe Natalie can read it to me. And then the I is the information or the what. So the information behind that point or location. So this is all the data about like a survey data or interview data. It can be information about a street address, about a person. So that's what the information is. It's the data behind the data. And then of course the S is system. That's going to be hardware, your software, your data models that you use, your methodology, your tools. That's going to be how you work with that data. So what you're paying for? What is spatial data? Spatial data is any data that has direct or indirect reference to a specific location. So any data that has a geographic location, which is almost all data on the Earth. I mean, almost all data has some point that is geographic to it. So that's why it's important to have an idea of how to handle it. So it's referred to as geospatial data or geographic information. You can, anything you want to call it there. Some examples would be tabular data. So if you have a spreadsheet, which we'll talk about how to deal with, if you have a spreadsheet with, say, addresses in it, you can have points on a map. So a city's states or anything like that, census tracts. And then you have satellite imagery, aerial imagery, temperature data, density data, and historic maps. These are all types of spatial data. But within that spatial data, there's two terms that you have to know before we move forward. So we have to talk about vector and raster. And if you hear any GIS talk, these are always mentioned. So vector data is going to be your geometric shape data. It's going to be points, lines, polygons. So points like a city, line like rivers, like railroads, like roads, polygons like state boundaries that are enclosed from end to end. And you'll see in the graphic in the middle, there's examples of these. Its top is the vector and the bottom is the raster. Raster is represented by pixels. And so instead of points, lines, and polygons, you have actual pixel data. Each pixel has a value. And so that is how you're mapping stuff like data like historic maps. So you have a scanned historic map in, like we work with a lot. Scanned historic map, and you need to you georeferences it to put it in the real world space. So that's a raster data set. Satellite imagery, temperature, all these are raster. So there's this two types of data, spatial data types, vector and raster. Okay, so what is the problem? Well, students, faculty, and staff are often interested in learning GIS or integrating some kind of GIS or just to make a map into their research. So, however, the spatial scale at which they are looking is extremely varied. It's not consistent and it's not at the same scale. So that's one problem. Another is GIS data can be difficult to find for specific cases. So some cases of research that you might want to look for data, it can be difficult to find a spatially located data set. And so often you have to create it from scratch. Well, how do you go about that? And then finally, GIS software systems have a learning curve. So as with almost any software package, there is going to be a learning curve associated with it. And it may not be that. You also have to learn about the tools within the software. So if you're not using it on a daily basis, like we do in so many things, you lose it quickly. So being upfront and aware of that is very important. So taking a wide breadth here, some of the stakeholders that you might encounter using spatial data are anthropology, biology, chemistry, engineering, education, humanities, digital humanities a lot will be using it, and a lot of medical center, the VUMC or the Vanderbilt Medical Center utilizes a lot of spatial mapping. And of course, makes sense to you. Other types of data, like I mentioned, are historical documents that you may be able to pull. So for our Battle of Nashville project, we have to go into the archives to pull out historical accounts of locations to map. So using historical documents, books, lab notebooks, GPX data or GPS data taken from the field, from a handheld GPS or a total station, census data. Oh, such a wealth of geospatial data. It's fantastic. CAD drawings. So if you're an engineer and you're doing engineering or land surveying, you have CAD drawings to be able to put into a GIS system. And of course, we've all been in and played around in Google Earth, and you can actually extract from there KMLs, which will then be imported into a GIS. So you can map them as your own layer. So these are all ways in which people use the data, spatial data. Now, I think it's important that we start off with how do we just set up a workflow? So we have a research question that involves geospatial or spatial data. How do we establish this workflow so we can be efficient and successful? Again, this is important to remember that we've had a lot of students who have different scales of data that we're looking at. So when you establish a workflow that allows users to understand how they will tackle the GIS for their specific case. So how we do this is we need to start off with a few ground rules. First, you got to frame your research question. And the reason I mentioned thinking spatially in the very beginning is because you want to frame your research question from a spatial point of view. So if you're working with spatial data, you want to have a spatial question. So frame your research question. Next, deep dive, treasure hunt, get into and explore and acquire possible data sources. And we'll talk about some really good practices for that shortly. Determine what's your final outcome. Are you going to make a static map? Are you going to make a web map? Are you going to make an interactive map? Just think about how you want your audience to perceive your information. Finally, design your methodology of how you're going to work with your tools in your project. Then examine, review, and then modify. You're going to see the one thing you're going to find out, like any scientific project, is that you're going to have to get to a certain point, then you have to go back to step one and modify your research question and your analysis. So that's going to have to happen. And then finally, which is the fun part, is the cartographic part or the making the visual project. And sometimes that can take a long time to make it very usable and for your audience. So when you're communicating your purpose, it's always important to remember why you're using spatial representation. Will your map or a visual enhance the meaning of that message to a particular audience? Keeping your audience in mind. So who is that audience? Why do they want to see this? Why do they need to see it? And how are they going to be able to visually interpret it really easily at the end of the day? And what type of format, the print, interactive, exactly the same things there. And what are some of your component objectives? So how is your data represented currently? And then what will you have to do to your data to make it more accessible, more usable, and be able to work with it? Now, I'm going to turn it over to Natalie to talk about some of the data issues and best practices.
Thanks. So this is sort of getting at the second problem that we've identified, that GIS data is very difficult to find. And in often cases, you kind of have to start from scratch or build on existing data and geo-enrich it with additional information. So we kind of have come at this from the perspective of providing assistance on how to search for and create data to empower users to take ownership of their project. One of the biggest requests that Stacy and I get is, how do I find this data? How do I create this data? We had an example of a student who was working with a poetry book that had locations, and they wanted to translate that onto a map. How do I get the locations that this author is describing out of the book and into a GIS? And this is sort of some of the best practices for that. So before you begin, if you are able to find data or you're crowdsourcing data, you want to ask, where does this data come from? What format are you ingesting it from? And what type of data are you working with? Are you going to have to create your own data? And also looking at metadata, which is data about data. How current is this data? Was it made in 2010? If you're looking at population trends for now, you probably don't want to use that data set because it's a little bit old. And what type of data do you need to create the map that you have envisioned in your mind? Do you need date locations to bring in that element of time? Are you looking for density analysis? Are you looking to make a thematic map? Do you need to go out and get data with a GPS? Just thinking about like how you're going to format your data and what kind of data you need to come to this ultimate goal of your project. So in thinking about all of this, you want to think about what type of data you need. Do you need discrete or continuous data? So discrete data is individually distinguishable phenomenon that don't exist between observations. So discrete data we typically see with our vector data sets. Continuous data is data that has a gradual variation or range of values. And this is the type of data that we typically see with raster data. So just based on the type of data you would need, you kind of have to decide if you're looking for vector or raster data. And this is going to help you narrow down the data that you're searching for in these different databases. But you also want to think about scale, resolution, and what tools you're going to be using. Data management is a huge part of GIS. There's so many things that happen when you don't have your data organized correctly, especially because GIS can be rather picky, especially using like QGIS, which is an open GIS data software, and ArcGIS. If you move files, things get broken. So it's important to have a plan for where you're going to keep your data, how you're going to keep it organized. We usually like to say to have a working folder that someone sets up, and then a series of folders that keep our different types of data. So, we've got a raster data file, a shape file, which is a type of vector data, and then we've got our final maps. We want to have this done in the front end rather than the back end, because it's really hard to start organizing stuff after you've already connected your data in your GIS. So there's a huge issue and often forgotten. Even we are guilty of it, and we are GIS professionals. So it's just always good to start thinking about on the front end and to build good data management practices. GIS is also like the software systems are very picky about naming. You can't have spaces in your names, and that's often kind of a weird thing for first-time GIS users. So you have to use an underscore in place of a space. You want to be really smart about how you're naming your files. So not test 1, test 2, but adding in like the name of the location. So if you had Nashville Streets underscore today's date. And then if you run any analysis tools, it's good to put the name of the tool and the date that you ran it, so you can see in your GIS system very clearly like which one has been run and which is the most current one, because it gets a little bit tricky when you've ran a clip on your data 3 different times and it's just called clip 1, 2, and 3, and you're like, shoot, which one was the most current one? So this is, again, very, very important to get on the front end correct. So our best practices with data is to make sure you are tracking down and documenting where you're getting your data from, and also checking the metadata or creating metadata about your data. Trying to not have too many nested folder systems, just because it can get a little bit messy. Ensuring that you are keeping an original copy of anything that you downloaded. So if you download a copy of data and then you make some modifications for it, keep a clean copy from where you first downloaded it, and then call your new data that you've modified _modified. And also to back up, you want to make sure that you have a copy of your working folder somewhere. So you want 3 copies, 2 different media, 1 copy offsite. We have a lot of cloud systems, so we typically say like work locally, but back up to the cloud so you can access it if something were to happen. So alluding to cloud platforms, we use OneDrive here at Vanderbilt, and it can cause a ton of errors if you're trying to work directly off of OneDrive. I think we've all probably dealt with the issue where you're trying to go into a folder and like not everything's downloaded correctly. That's a huge pitfall if you're doing GIS, because typically it is drawing from multiple files to render in the GIS software system. And so it becomes a big issue when you have your data stored on OneDrive and it hasn't downloaded all the different files necessary to visualize. So we like to say work locally on like a C drive or a flash drive, an external hard drive, and then push up your product, weekly, bi-weekly, and always keep like a version of your finalized data on a cloud platform or a server or Google Drive, wherever you keep it, as sort of a backup, and then your working folder stays local. Shapefiles are a type of file format that we use quite often in GIS, and something that's a bit tricky about them is that for one shapefile, there are at least 4 other little files in the File Explorer window that you have to have. They can get messy in your folders, your working folders. So we like to say have a dedicated folder for your shapefiles that all of those are kept in. And then make sure that you store any downloaded data in a dedicated working folder to avoid errors. So sometimes we will download data and we keep it in our downloads folder, and then we clear out our downloads folder and our data is gone. We want to make sure we're downloading it and then unzipping it or copying it over to our working folder to make sure that we don't have broken connections. So metadata, I've alluded to it a bit. Metadata is essentially data about data. So it gives information on the quality, condition, origin, and other characteristics of data. So this is an example of some metadata for a Warren County, Mississippi map. It tells us what this data is, gives us tags, keywords about the data, tells us how the data was created, who to credit when we create our map, if there's any use limitations. So sometimes you're not allowed to use the data if you're not a government organization, etc. And it will, if you've got information about the attributes or codes that are in there, it should also include a data dictionary or code book. And it gives us everything from how this was created to how accurate it is, the resolution, scale, projection, all important to know. So with geospatial data, we want to do sort of a quality check on this before we start using it. Again, we want to ask, does it have metadata and documentation so that if I'm opening an attribute table and getting that I in GIS, the information about a place, it's clear to me what that information is saying. We want to make sure that we know where the data came from, who created this, is it a reliable source? Do my attribute fields, are they meaningful and clearly named? One thing that is always a big issue with census data is you get sort of the GIS data in the form of a shapefile, and then you have to do something called a join to join it to additional attribute information. And the attributes have these little code names. And so you don't always know what those mean. So you want to make sure you have the code book to know what those specific attribute names mean. You want to make sure there's a coordinate system that's clearly defined and is appropriate for the area that you're working in. Coordinate systems are a huge issue in GIS. If you don't get them right from the start, it can mess up your entire project. So you want to make sure that, number one, there is a coordinate system for the data set you're working on, and number two, it's appropriate for the types of analysis that you want to do. Some are better for doing analysis like measurements. Some are better for preserving shape. So there's lots of different considerations, and we filled a lot of questions about that. And then also, do we know the scale and resolution of this data, and is it accurate and precise to where we are trying to geolocate our information? One of the biggest requests we get is, I need Nashville streets GIS data. And so we want to empower people to be able to find data themselves. There's tons of different ways you can find data through things called open data portals. So Nashville, most cities, large cities have open data portals for GIS. There's something called ArcGIS Hub that has data from open data portals across the world. Something called the Living Atlas, where you can query this data. We have tons of government data sets, things like Census Bureau, the NIH has a lot of data, CDC, all those. Social Explorer, which is kind of like a subset of census data that just makes it a bit easier to query. IPUMS, which is historic GIS data for Census Bureau. And then Google keyword search. So how do you search for GIS data using Google? So here's an example of some open data portals for Tennessee. TennesseeGIS.org is just for Tennessee data in general. And then the Nashville open data portal is data.nashville.gov. So we want students and faculty and staff to be able to look for GIS data on their own. And there's some specific ways that you can search for it that are more successful than others. So you want to think about where you're looking for the data, your specific geographic location, what you want to know about that location, and when you're trying to get it. So the thing that you want to do is make sure that you are querying your data and adding keywords such as GIS data, shapefile, if you wanted raster information, raster data set, and then looking for reputable sites that are known organizations or government entities where it would make sense that that data is living. So you want to try to search by having the place name, so for example, Nashville, and a keyword. So here's some examples of keywords: Nashville Open Data, Nashville Open Data GIS, Nashville Data GIS, Nashville shapefiles, or Nashville Streets shapefiles. So you want to get specific. If you wanted just GIS data about Nashville, you might say Nashville GIS. But if you wanted to know something about Census Bureau blocks in Nashville, Nashville Census Bureau blocks, GIS data. So basically coming up with these keywords and being able to search more effectively. So you've gone through all these steps, you've looked for your GIS data, and you haven't been able to find it. It's pretty common, more common than you might think. So what do? Do you think that there should be data? You have to ask yourself, do you expect there to be data, and where do you think this data would live? And try to seek those sources out. Start to think to yourself, are you thinking about your research problem correctly? Are you thinking about it spatially? Do you need to come at it from a different perspective? Are there other people that you can talk to that might be having similar issues, that might have suggestions about potential data sources? And if all else fails, can you collect or source your own data and create it? So if it turns out you can create, your own data, this is pretty common with some of the humanities groups that we work with. What do? You're going to create data in the form of something called tabular data or a CSV file. So with tabular data sets, you always want to make sure you have headers for each of your columns, that each column is an attribute. So each piece of information that you would want to know about a place is associated with a specific attribute field. So in this example, we have parcels, so like parcel data in a city, and then we have the address, which is like the street address. Then in a separate column, we have zip code, and then in a separate column, we have state. So each of those is a piece of information that we want to know that also corresponds with a separate attribute field. We don't want to concatenate fields because it can cause issues in being able to query and run analyses. We always want to use CSVs, and we want to keep our tabular data at the same spatial scale. So if we're looking at address data, we want to have only address data. If we're looking at zip code data, we want to have only zip code data. It just makes it a little bit easier to not have a data set that compares across spatial scale. We want to keep it at one comparable spatial scale. So an example of how we might set up some address data is maybe I had a list of locations around Nashville that I wanted to map. And I knew what all the street addresses were, but I would need to create a CSV file for these. Well, what I would do is I would create one attribute that's called place description. So if it was a list of houses of GIS users in Nashville. This would be my house. I would have my address, which is my street address location. I'd have a city feature or a city attribute, Nashville, a state attribute, Tennessee, and a zip code attribute. And see how these are all broken up into separate columns. That's how GIS is going to best ingest this information. So in many cases, you might have additional things you want to know about your place. So for example, maybe I want to know about colors of homes of GIS users in Nashville. And I want to know the top 3 colors of them. And so it might seem like the way to do that would be to have a attribute for the place and then an attribute for the color. And you would say red, blue, and yellow. Except now you can't query and find out what the most common color is, and then what the second most common color is, and the third most common color is. So the way that you would want to break that up is have your place as an attribute, and then you would have multiple fields, color 1, color 2, color 3. And that allows you to do additional analyses in GIS that you couldn't do if you had these fields concatenated. And this is just sort of a weird way that you have to think spatially and flip the way you would usually think about data collection. So some of the major pitfalls with GIS: if you put garbage in, you get garbage out. So this really addresses our third problem, which is that GIS software systems tend to have a pretty big learning curve. And if you're not using it every day, it can be confusing and a bit hard to keep track of. So we want to warn users against common mistakes up front so that the enormity of using GIS is alleviated. Common errors that we see are errors with scale, projection, accuracy, imposition, age of data, and bias. So especially bias, you want to think about when you're creating a map. Why are you creating this map? And you want to check your own bias and then also the bias of the data. You know, who created this? Was it created by Facebook? What sort of implications and interests might Facebook have in creating a GIS data set like this? And then also from your end, why are you creating this? What sort of interests might you be serving in creating this GIS product? So speaking to scale, it's a little bit confusing with GIS. So something that is large scale will have, so in this example, a 1 to 24,000 scale is large scale because you can see a lot more features and a lot more specificity. Something that's small scale is going to be more zoomed out, so a 1 to 100,000 scale, and you're going to see less specificity, less details. So you see as the number on the right gets smaller, the scale gets larger. And so the other major issue, the other major issue that we see, and I've actually been dealing with this on a project this semester, is projections and coordinate systems. We're not going to talk in depth about projections and coordinate systems today because we could spend 3 hours talking to you about how to pick the correct projection and coordinate system from your project. Stacy and I talk about it ad nauseum. Like her and I will say, what would you use for this? And she'd say, well, here's what I'd use. And I'd say, but what about this? So oftentimes you're going to get data and it's going to show up in a different coordinate system that you're interested in. And you're going to have to do something called project it. And this basically transforms your data to a different coordinate system that's more appropriate for the type of analysis that you want to do. The main goal here is to minimize error and distortion for the research goals that you have. If you don't understand projections and coordinate systems, you can corrupt your data very easily, and you end up in something called Null Island, which is a fictional place that's at 0, 0 on the world. And your data is very small looking, it's not spatially scaled, and it's literally in the middle of the ocean. And then you're sad because your data is corrupt, you can't do any analysis with it, and you're panicked a little bit because you've put a lot of work into creating this data and then now it's not really usable. So you can see just how confusing projections are with this graphic at the bottom. So here's the green is like unprojected data for the US. And then if you used a Lambert conformal conic projection, you can see how it alters the kind of shape and distortion of the states. And then if you use a Mercator projection, which is what we typically see in sort of the United States maps that keeps it kind of planar and flat, again, there's more distortion and that we see with this. And especially in places like Maine, you can see there's like a lot of difference. Florida, California, and Oregon, like those coastal areas, having the wrong projection can kind of take your analysis off pretty large. So you want to think about coordinate systems. There's a lot to think about, and we're always here to support people on this front because I feel like it's a question that we get a lot. You just want to think about where in the world you're working. You know, are you working in the US? Are you working in a different country? What type of scale you're trying to look at. So are you looking at small scale, large extent? So you're at like a world or state region level. Or are you looking at large scale, small extent, a county or city? What types of measurements are you going to do? Are you going to just look at simple locations? You're probably good with just a geographic coordinate system like a WGS 84. That's perfectly good. If you're doing distances, you probably want something like an equidistant projected coordinate system because it's going to preserve distance for you. And you can do things like buffering and length analysis. If you're looking at areas, you're going to want something called an equal area projected coordinate system that will preserve true area. And then you want to think about if you were able to get data from a source, what is the coordinate system that it's in? And is that right for what kind of analysis you're doing? And then also, especially with raster data, thinking about if you decide to change your coordinate system, how will this affect your data? And that's really more about resampling of raster data, which is kind of a whole issue in some cases.
Okay, well, I'm going to take, thank you, Natalie, so much for providing such a good overview of kind of some things to look out for, our best practices. I can't thank you enough. So we've created this workshop that we hold every semester, and sometimes we do it ad hoc for different departments, like digital humanities will get it. We've created some tutorials here. For our workshop series this year, we actually have a, let's see if I can look at it here. We do it every year a little different, but this year we always start off with a GIS basics, which we talk about what is GIS? Why do I want to use GIS? Why is it important? And then we start talking about the actual software, the system part of the Geographic Information System. So at Vanderbilt, we're very, very lucky that we have a robust Esri license. So we have ARC Pro, which we do actually a 2-day workshop on ARC Pro because there's so much to do. And we cover all the different data types. We also do the best practices, which we hold here, and we have all our materials. We've created tutorials and walkthroughs and using real data from Nashville for all of our tutorials that we've created. This year we did a georeferencing, so taking that historic map raster and then getting it into the real world from Null Island, retrieving it from Null Island. This year we did cartographic map design because sometimes that's an afterthought, how to make a proper map. And then we also do, any type of software. We do, if you don't have Esri projects, we have a solution for you. It's called QGIS. It's an open source free. It's available on a Mac and a PC, and we do extensive instruction on that as well. So that was our workshop series for this semester. We'll do it up again next semester with a different flair. And then I'm going to put these in the chat here in just a second. These in the chat. I'm going to put, oops, look at this. Oops, it's still in there. I will put this in the chat. Link. Put this. This is the document that I wanted to really share with everyone today because we're all about sharing our curriculum and our instruction that's worked for us. So this is a link to that. It's our best practices workshop guide. And it goes over some of the things that were in the PowerPoint presentation, but it actually outlines how you actually frame your question. So go into answering some questions about your analysis. What type of analysis do you want to choose? Because there's so many different ones. You'll have to do some literature research, maybe some of that. How you perform the analysis, examining results, and visualization. So it's like a checklist of how to do this. And the big believer in understanding garbage in, garbage out, because GIS is one of the most common places or applications that if you put garbage data in, you're not going to get a good result and you're going to get garbage out. So understanding this phenomenon and how it will, understanding the errors that Natalie mentioned, the inaccuracies that you have to look out for, and imprecisions of your data, knowing your data going in will help you minimize this error and avoid the garbage in and garbage out. Also in here, it's really nice. I've included some, we put in some accuracy, precision, error, and then propagation of error. And propagation of error is where you've introduced an error with your data, and then it just gets worse and worse and worse and worse as you continue to do run analysis tools. So by the end of the day, you've got nothing worth it. You've kind of wasted your time. So some good terminology here. This is what Natalie spoke to greatly here. Like here's the scale. Knowing the age of your data is important because depending on when you want to, so we work with historic data all the time. So that's not the biggest problem. But if you're working on something that's like COVID data or something like that, you want to know the age of that data. It's important to know. Coordinate systems. And then we also have that bias. And I cannot emphasize this, your bias, audience bias, but also those coordinates and projections that we've talked about previously. Those are often the biggest way to promote a bias. So by skewing the Earth's surface can change how an audience will view your data. So keeping that in mind. So they kind of work together. Here's a great example. Here's what Natalie went over with your address data, how to format that. Remember, use a CSV. And then just for fun and enjoyment, if you have access to an ArcGIS online account, and if you don't, that's fine. But there's a few hands-on here in case you want to try working with some of this tabular data and trying some of these techniques in here as well with some data that we've created. And then we'll go in here at the very bottom and you'll have further resources. There is a project planning template that we've created that helps you sometimes it's helpful to storyboard out your research project. So going ahead and putting out your question and having this template to help you design your project. I'm sure a lot of you are familiar with OpenRefine. It's a great way to clean up some nasty data. So there's a tutorial in here, as well as how to cite geographic data. Geographic data is not cited like normal books and literature. It has a different way. So there's different links here on how to properly sort these new visualizations that are out there. And then there's some other data links. And we're both into business story maps right now. So we got some story map helpful, fun links to check out. So this is just a way for you to take a look and start to get familiar if you're interested in, or someone you know is interested in working with geospatial data. And with that, I will stop sharing. And we could take any questions. I think we have a couple minutes. Oh, great. Yeah, I love talking about how we got into, I'll let Natalie share hers as well. But I was in undergraduate school at Appalachian State in Boone, North Carolina. And I had I just kind of tried every single discipline I could think out. I've been an English major, psychology major, high school education major. And I had a professor say, do you want to make some maps for me? And that was it. And so then I said, yes, I want to make some maps. Now I want to go to grad school, get my master's in geography. And I said, no, I want to do a PhD in geography. So I was hooked. So what about you, Natalie?
I was a former environmental scientist and then really wanted to be a park ranger at one point, and it just didn't work out. And so ended up going back to grad school at Tennessee Tech, where they have a program in environmental informatics, which I had always been interested in GIS and map making. And this program kind of bridged my experience with environmental science with map making and GIS. And I ended up really enjoying that program and then getting more hooked on the GIS part rather than the environmental science part. And here I am 3 years later.
And I think what's so neat about we have such a lack of GIS resources on campus, the fact that Natalie and I can come at it from two different perspectives and reach so many more people. I think that has been a real plus for the university and for our sanity as well. So.
Yeah, luckily, Stacy and I worked on so many projects between the two of us that I think at this point, if there's a question about a specific application of GIS, one of us will have a bit of insight about it because we've worked on just such a wide breadth of projects across multiple disciplines, and then different entities. Like Stacy has worked different places and I work different places, and you get a little bit of different experience and flavor from each of those.
Thank y'all so much. We had one question come through, but I think you did it. Were you going to share the URL to the document in chat? Great
Yes.
presentation, they said.
It's the document is in chat.
Okay.
And if you would like, any other resources, we're really open about sharing our the successful instruction that curriculum that we've created. And every semester we change it up. So find our email. We'd love to chat with anyone offline.
Yeah, and our workshops are like open to anybody, really.
Yeah.
So if you're interested in coming to them, just email us and we can get you the link, and you're more than welcome to attend. And also, if you all don't have access to ArcGIS for your organization and you're interested in getting started with GIS, hit us up about QGIS. It's free, it's open source. You can use it on a Mac, which is great. We have a ton of Mac users, so Stacy and I are intimately familiar with QGIS at this point. So it can be kind of a great gateway into GIS, especially if you're a Mac user and totally new.
Thank y'all so much for presenting today. I would really like to show my appreciation to Dr. Curry Johnson and Natalie for joining us today. And stay right here because our final sessions will be at 4 o'clock. If anybody has any questions, let us know. Otherwise, stick around.
Thanks so much.
Thank you so much for having us.
Yes, thank you.
Both.